do the worksheets, I wanted to go back to something we had done in class today that I don't know what I typed in, but for some reason in my hurry it went wrong, and you may have seen me standing there kind of puzzled about it. I want to make sure I clarify that. So let me get this scale the way I want it. All right, we have a point right here at 1, 1 on a regular x squared graph. And then when I put in 1/5 next to the x, if I multiply the x before I square it, it's paired with the x. It looks like I should take 1/5 of the x or divide it by 5, but I do the opposite. I should see a stretch of like this point or any other point should stretch out instead of come in. It should be a horizontal stretch of 1, 2, 3, 4, 5. It should come out that way. And that's what I was expecting to see in class, so I must have typed something in wrong. But you see it's a horizontal stretch of 5. It didn't take it in 1/5, it took it out 5 times bigger. Every point is 5 times bigger than it used to be. Alright, so let's go to the worksheet now. So right now, if you find your worksheet 2 that I handed out in class or attached to the assignment. So right now we have an equation, y equals f of x. And we don't know exactly what the equation is. All we know is it's some function. And so if we take this picture and we multiply the x's by 3, a common sense might tell us that it stretches it horizontally 3, but it does the opposite of what it seems, and it's a horizontal shrink of 3 by a factor of 3. So all of these points, like this point at on the x-axis, this is x. So on the x-axis, all of the points that are going across will be divided by 3, not multiplied by 3. So what I mean is pick some points, like this point is out 1, 2, 3. If I say this number and shrink it in and say divided by 3, 3 divided by 3 is 1. So that point over here is going to be right here. And like this point up here is 6. 6 divided by 3 is 2. So this is going to shrink in to 2. 6 divided by 3 is 2. And just pick some convenient points. This point is 6. Out on the x-axis 6. Divided by 3 is 2. So it shrinks it a lot. This right here is 0 across, and 0 divided by 3 is 0. So right now, we just find a few points that you want to anchor it to. And right now we have this picture. That's what the 3 will do. It'll take this and squeeze it in. And you can literally take points and divide them by 3. 6 divided by 3 is 2. And that's how I got these points. Now I look at this negative. The negative is on the outside. So anything on the outside of the parentheses affects your graph up and down. Anything on the inside of the parentheses affects it left and right. So this is going to flip it over. And so this graph, this 6, this negative 6, is going to become 4, 5, a positive 6. And this negative 3 is going to become a positive 3. And so now it's going to flip it over like this. Now so far I hadn't even done the right graph. I mean, technically I should erase all of this. But I'm going to now move my whole graph down 5. And the red's going to be the answer. So I'm going to move this down 1, 2, 3, 4, 5. That's going to be the tippy top. I'm going to move this down 1, 2, 3, 4, 5. Move this down 5. And move this down 1, 2, 3, 4, 5. And the red is my final answer. All the rest should technically be erased. And this is my final answer right here. And so I'll do the other ones maybe more. If I was in class, I'd be able to like maybe do them dotted. In fact, I think I could probably do that. So I'll try that on the next one. Alright, so I'm basing everything on this original graph. This is my f of x, and we're going to change it in all these ways. Alright, this one, inside the parentheses, is a -3, so it's going to slide this whole graph across 3. And so this one's going to go over 1, 2, 3. This one's going to go over 1, 2, 3. It's going to kind of go off the screen. All right, so I'm going to take this at 3, -3. I'm going to move that point over 1, 2, 3. And I'm going to take this end point right here and move it over 1, 2, 3. And then this point, I'm going to slide it over 1, 2, 3. And this point, I'm going to slide it over. Find some anchor points at the ends in the vertex. 1, 2, 3. So it's going to be right here. So far, I'm not finished with the graph, but it's doing this little thing, and then straight up, and then over. And so it shifted this whole graph to the right 3. Now it also has a 1/3. The 1/3 is on the outside, and so since the 1/3 is on the outside, it does exactly as it seems. And so it's going to take all of these points and divide them by 3. This one right here is 6 divided by 3 is 1, 2, 3, is -2. -6 divided by 3 is -2. This one is at -3 divided by -3 is -1. So it's coming across like this, down like this, and back up like this. So that resulted in a vertical shrink. And my final answer, in fact, is this one. So it's like I took this graph and shifted it over 3 first, and then I did the shrink where I multiplied it 1/3 or divided by a 3. All right, this one, I see a 2 stuck next to the x in the parentheses. That means all of these x's on the original function are going to be not multiplied by 2, but the opposite. I'm going to divide them by 2. So this is kind of going to have some fractions in it probably. 3 divided by 2 is 3/2, which is 1 1/2. So I'm going to come down here and put a dot at 1 right there. This is 6 divided by 3 is 2. So I'm going to put a dot right here at 2. So 1, 2. Okay, sorry. All right, now the next one, this 6 divided by, okay, sorry, I knew I'd done something wrong. I shouldn't be dividing by 3. I should be dividing by 2. Okay, so 3 divided by 2, I think I started out with. 3 divided by 2 is 3 over 2, which is 1 1/2. I'm dividing by 2, so 6 divided by 2, this 6 across. 6 across divided by 2 would give me 3. 1, 2, 3. Okay, 0 divided by 3 is still 0. 1, 2, 3. And so it doesn't do anything this way. And then 6 divided by 3, like going across, 6 across, divided by -6 divided by 3. I'm sorry, divided by 2 is -3. So I'm dividing -6 by 2 and I get -3. All right, so that's just the first step is I divided it by 2 and it's called a horizontal shrink. And so I have this picture right now. So it was a horizontal shrink. All right, then the last thing I do is this. Things on the outside do exactly as they seem. And so I'm going to take all my y values, because on the outside it affects my graph up and down, and I'm going to multiply them by 1/2 or take half of them. Half of -6 is -3. Half of up and down, -3 is -1 1/2. And so now I have this. It's a vertical stretch, vertical shrink. So the 1/2 on the outside caused a vertical shrink. The 2 on the inside caused a horizontal shrink. All right, now we're on this one. This means to rotate it over the y-axis and change your x's this way. This negative means whatever was up here goes down here, whatever was down here goes up here. The ones on the outside flip it vertically, on the inside flips it horizontally. So let's go back to our original. This across 3 this way is going to flip around and be a -3. And so this -6 is going to flip over here. This 6 is going to become a -6 because it's saying take the negative of your x's. If I'm taking the negative of my x's, that's what I'm doing. Whatever is over here at 1, 2, 3, 4, 5, 6 across is going to be back here at 6. Back to your original. And there's no need to flip something that's on the axis. You can't do that. This -6 is going to flip over and become a +6. So I'm rotating it completely around. And this part didn't flip because it's right on the axis. And so it flipped this way, like straight, straight, and the curve's going this way now. So I just flipped it over that should be dotted. Dotted because I'm really don't have the graph yet. Okay, so that little curvy part flipped. Now I've got this flip to do, the negative on the outside. And so this -6 becomes a 1, 2, 3, 4, 5, 6. This -3 becomes a +3. So I have this. And that's my final answer. So technically, I should get rid of all of this. You know, these are my final answers here. It's okay on a test if you want to dot it in along the way though. All right, let's see what all happens with this one. All right, one thing I'm going to teach you to do over the next few days is set the parentheses equal to 0. So I'm going to set 3x minus 3 equal to 0. And that's going to give me 3x equals 3. Which gives me x equals 1. So in a few minutes, it tells me to slide this thing to the right 1. You have to find out what makes this 0. Like, it won't slide to the right 3. For instance, here, what made this 0 was 3. X minus 3 equals 0. I'll say it in just a minute. X minus 3 equals 0. And when you solve that, you get x equals 3. So this graph right here, I slid over to I slid this originally over 3 units. So what I've taught you so far is if it's paired with x, it goes left or right. But I haven't told you what to do if it's paired with something else like 3x, and so now I am. Take your parentheses and set it equal to 0, and it'll tell you how far to move it. But don't do that yet. First, you've got to do the multiplication. Remember, if it's stuck to x, it does the opposite of its seams. So instead of multiplying by 3, I'm going to actually take all of my x's and I'm going to divide them by 3. I'm going to do the opposite. So let's go back to our x's across. This 3 divided by 3 is 1. The 6 that I had was divided by 3 is 2. 0 divided by 3 is 0. And the -6 that was out here divided by 3 is -2. So far what this does, that 3, is it causes a horizontal shrink. Then you finish out the inside, you move it right 1, not right 3. So now I'm going to shift all of this over to the right 1. Let's see if we can get another color and make it dotted. Okay, so now I'm going to shift this all over to the right one. Okay, so now it's here, like that. And I've done all of the inside now. And then I do the 1/2, that's on the outside, so it does the opposite of what it seems. So I take half of, I'm sorry, it's on the outside, so it does exactly as it seems, and it affects it vertically if it's hanging on the outside. That means take half of all of your y's. Half of 3, -3 is -1.5. I'm doing it this way. Half of 6 is -3. And so you have this for your final answer on the last one. All right, now let's go to worksheet 3. And see what happens there. All right, on worksheet 3, all right, we're given this f of x. And so they put it on every single one of these, so we have something to look at is what's happening. And so, you know, in the last one, I only had it on the first screen. Now f of x is here, and they want me to do this to it. So I'm going to take f of x and shift this, all of this up 3. So that's 2, shift it up 3, 3, shift this up 3, and take this one up 1, 2, 3. And connect it. That should be straight. Sorry, I'm drawing with my cursor. And so that should be straight. All right, this one, now look, this is paired with just one x, with x. If you set that equal to 0, it tells you to move back 2. So it's going to be 1, 2. Move this one back 2. Move this one back 2. And move this one back 2. Connect your dots. And all of that slides back too. This one is on the outside. If it was on the inside, it would flip it this way. Since it's on the outside, it flips your y's. So my y is going to flip down here. This one's going to flip down here. And what's underneath is going to flip up here. And 0 doesn't flip. And so where it was going up, it's coming down, across, straight across, sorry, and up. Alright, so now what will this do? It's paired with just plain old x, so it's going to move it to the right 1. 1, 1, 1, 1. That's pretty easy. Just going to move it to the right 1, and this is your new graph of whatever the function is. Look at the inside here. Nothing is done to x at all, so that means it doesn't change this way. This 2 is on the outside, so it causes a vertical stretch. It does exactly as it seems. Alright, so if I multiply this by 2, I get 4. 4. I multiply my y's by 2. 0 by 2 is 0. -2 by 2. Multiply -2 by 2, you get -4. And so it caused a stretch of this. And that's my new graph. All right, on this one, sorry, I had to enter a text. All right, on this one, move everything down 4. 1, 2, 3, 4. 1, 2, 3, 4. Move this down 1, 2, 3, 4. And move this one down 1, 2, 3, 4. 1, 2, 3, 4. Okay, so my new graph is like this. Alright, this one, nothing's done to x, so we don't do anything this way. This causes a vertical shrink. You take half of all of these numbers. Half of 2 is 1. Half of 2 is 1. Half of 0 is 0. Half of -2 is -1. It causes a vertical shrink. So this graph shrinks vertically. This is straight across and then down. All right, on this one, it's telling me to change my x's, flip them across. So 4 becomes -4. This one flips over here. If it's on the axis, it doesn't flip. And this one flips over here. And so I have this picture that should be straight. So it should look like it flipped over. This one, the 2 is paired with the x, so it causes a horizontal shrink. It looks like I should multiply my x's by 2, but I do the opposite and divide my x's by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. 0 divided by 2 is 0. You see I'm taking the outside points. And across, -4 divided by 2 is -2. And so I have, that should be straight across, down. And so it caused a horizontal shrink.